So hi, I show you how you can set the target temperature of one system you're doing. So I have this time set up here, a heatsink and furnace connected together, and a temperature probe. Let's use this, and let's use the temperature probe here to set the target, and only the temperature probe. So the temperature probe itself have a PID inside the code. The code of this have a PID, so we can use this to set the temperature. So let's choose value for to this. I will choose 18 degrees as a target. So this system will try to maintain the temperature here, right? You need to another value is the precision. I'm naming precision, but how we can see is a very important value. So I will just put 10 degrees here to show you. So basically I have a target and imprecision, and these ones we need to calculate a border. So we have 18 degrees as target, but can be less than degrees. So this means 70 degrees of low, and 18 plus 10 is 19. So the temperature will be controlled is between here. Okay, so this value we will need to use this to set up the probe. So the higher value here is 19, so let's put the higher value in the low one and exactly the opposite. So we put 17 in the high one. Let's validate, and it's just there like magic. You can see it's 15. If I connect here, it will be set to 18. Amazing. So if you change the system for some reason, it will be retoggled here and it'll try to put the temperature again the 18. If you move, we try again. How we can see is a very precise system, right? So we can use other values. Here is like 1, so this means a more precise system. So if you use 1 here, I will have the 18 less 1, right? So now the borrow, sorry, now the low value will be 79 and the top one will be 81. So it's just the target plus the imprecision. So let's put this value here. 7, sorry, 18 plus 1 is 81, and 18 less 1 is 79. So just like magic, now the temperature will be very close to the target, and it's basically that. One thing you need to pay attention is this value here, how you can, I'll say for you, this impacting in others behaviors. So basically, if you have a graph plot and this is the U target temperature, so this is your target. If you see the temperature here, the in your system will be something like that. So it's an oscillation behavior. Alright, so if you put a higher value here, the system will be, oh sorry, if you put a low value here, the system will be more aggressive to try to maintain this value here. So you have a less error. So the system is extremely aggressive to try to maintain the value, and this is not a good thing. So your temperature will be something like that. The values be very far away from your target. I can see this using a data log. So I can see here you have an oscillation behavior. Alright. So need to try some values to use like this, depend on your system. So if you put more regulators, now the oscillation will be worst, how you can see. It's trying to maintain, but it's oscillating a lot. So depends what you want, right? He's basically there. Thanks for watching.